through and interpret this as I see it, or do
Yes.
the back? Which first?
Let's go interpret this.
Interpret this. Okay. So, acceleration. I think that he means that he wants you to know that acceleration is velocity divided by time. And if he gave you a velocity and a time and asked for acceleration, but you'd know to divide velocity by time to get acceleration, maybe he would want you to be able to give velocity if given acceleration and time, and give time if given acceleration and velocity. So basically, your equation is, may I write on this?
Mm-hmm.
Your equation is acceleration equals velocity over time.
I'm going to report this too.
Okay. And basically, he would want you, if given two pieces of the puzzle, to get the third piece, no matter which the two pieces were. Do you see what I'm saying?
Yes.
And you'd use algebra to get that. Okay, compounds. So to me, if he says he wants you to know compounds, then he wants you to be able to do something like this, where you're given some compounds and then you have to say whether it's ionic or covalent, and then be able to name it. Or if he gives you the name, like here, and asks you to write the compound. I think that that's what he means by compounds. Galileo, what did he tell us? What does that say? OS?
It's supposed to be us, yeah.
What? Oh, I read that. What did he tell us? And then straight line. Okay, so to me, that is that little section in here where it's all about Galileo and what he did. So this part's a little bit like history, where you just are memorizing stuff that someone did a long time ago, you know? And he'll probably just have a few questions about that. If not activated, don't know. Okay, normal motion is rest or straight line. So I think that this might refer to this bold part that's under the Galileo stuff. But I don't know what the straight line part refers to. But I think it refers to the thing in bold, and hey, it's in bold, so it's important, and it comes in the middle of that Galileo stuff, and this came right after the Galileo stuff. Okay, multi-vector. Multi-vector makes me think that it has something to do with these kinds of problems where you're going east and then north. So east is a vector, north is a vector, and then you have a resultant vector. It might have to do, and this is another sort of vector problem, it might have to do with something like this. The only reason I'm hesitant about it is because I didn't see anything like this on your quiz, but this is just kind of telling you that if you go here, here, and here, then it's the same as if you went straight. That's the resultant vector of going in these directions. And then this stuff is kind of like what was on your quiz, and it doesn't say anything else about vectors, so I don't know what the multi is for. Okay, moles per liter. Moles per liter. We went over this like a few weeks ago. I think this might have been chapter 2. Moles per liter is, okay, so molarity equals the number of moles over the number of liters. And y'all have homework about this. Not quite, but y'all have homework about this because I remember helping y'all with it. And then here, moles divided by liter, molarity, so that's kind of the same thing. And then a mole, for what a mole means, I think what he wants you to know is that 6.022 times 10 to the 23rd of something equals 1 mole. So as for what it could be pencils, or it could be atoms, or it could be molecules, or it could be ions, it could be tables, it could be anything, but in chemistry it's probably going to be those things, right? So this is like a dozen. 12 equals 1 dozen. So it could be 12 eggs equals a dozen eggs, or 12 socks equals a dozen socks. This much atoms equals a mole of atoms. AMU to grams. You know, this part I'm always so bad about knowing because you just don't talk about it much the rest of the semester, but it's always at the beginning of the chapter that teaches you about grams. So I think that it'll be at the beginning of your chapter. No, because y'all are being tested on chapters 3 and 4 only.
So we think.
Yeah.
With him, you never know.
So it probably mentions AMUs in here. It stands for atomic mass units, and I just always have to look it up. Atomic mass units. So I would say probably memorize its definition, and then mole, abbreviated mole, interchangeably, gram, atomic mass, replace, yeah, see, this is, to find this value, replace AMU with grams. That's probably what he means here, and this is exactly why I always forget about it, because you can just use grams, and that's what gets used in problems more.
Maybe he's just saying don't use AMU, use grams.
Probably the relationship between the two, which is you can replace AMU with grams, but you're probably going to need to know that atomic mass unit is a relative unit comparing one atom, blah, blah, blah. The definition. 5 types of reactions. Okay, so this is the piece of paper that you just took a picture of. Then she just gave to you. Okay, so thank you. 5 types of reactions. That's this whole thing. Decomposition is one of them. Units of acceleration. So the units of acceleration can be meters per second squared. That's the common one. It's usually it's always a distance over time squared. Meters per second squared is the only one that makes sense to me just off the top of my head, but in theory you could have like miles per hour squared. I've just never ever seen it. He probably lists it somewhere though. Deceleration. See, meters per second squared is what's said here. Let's just say meters per second squared, because that's what's most commonly used, and I don't see this having anything else. Balancing equations. So balancing equations is working those problems like is at the beginning. This quiz makes you balance equations. So working these problems. Empirical formula. So empirical formula, that was what y'all were telling me about from your chapter 3 homework a week or 2 ago. These problems, empirical formula stuff, and you have some in your homework too. So 7 and 8A. Why we're not aware of going 400 miles per hour. So that's this constant velocity stuff. Let's see what else. Empirical formulas down here. Molar mass into empirical formula. That's kind of how it's done. Naming compounds. We kind of talked about that with compounds. Projectile motion. How to describe. So I haven't worked a lot of projectile motion problems with y'all. Average speed, electric signal, Air Force. I mean, I haven't seen any projectile motion stuff from you guys. I can get out the physics book and talk about it, but is he really going to? Do y'all have any problems where a projectile is being shot up?
Not that I can remember. In our
Maybe-
last lab, we did something with some cars and like made them go up, but that's
The thing with projectile motion is that it, like here you've got land and here's like the sky's up here and the ground's down here, and left and right, and so you've got something that gets kind of thrown up, but then it goes back down, so it kind of goes, it doesn't go straight up, it goes at an angle. But if he just says how to describe, oh, horizontally and vertically, so I'll bet what he's talking about. Y'all haven't really gotten there yet, but you know how you've got something that goes at an angle and then you break it down into east and north? So I haven't seen y'all do this yet, but it's coming, where if something is going not straight up and down and not straight side to side, then it's got a vertical component and it's got a horizontal component. And the stuff that y'all did here is the same stuff that you're going to do here for the next chapter or two, but maybe it doesn't seem to me that he's talked about it yet, so maybe he just wants y'all to know what I just told you. And that's it.
yeah.